Welcome everyone. In this video I will prove the law of cosines, which says that if you have a triangle like this one, which I will name as A, B, C, very conventional, then we name this side A, the side that the capital A sees, the angle A sees, is named small case a, and respectively B and C. Here, the small case letters represent the length of the sides and the uppercase letters represent the measures of the angles. So, the law of cosines states that, which is, as I said, our goal to prove it. We will prove it. Law of cosines states that if you are interested in, for example, finding a squared, let's say, then you simply do c squared plus b squared minus 2cb cosine of a. Alright, this is what the law tells us. And how can we prove this? How can we prove this? To make my proof, I will draw a perpendicular line like this to the side AC, which we named B. And I will name this line segment, the one in blue, X, and the red line, the perpendicular line, will be named Y. Here, from the Pythagorean theorem, we see that a squared is equal to x squared plus y squared because we have a right triangle here. So we got this one. Now, as you can see, in this equation, we have a squared on one side and something on the other side. Now, if you look at the law that we want to prove, we again have a squared on one side and we have another expression on the other side. So, if we can show that this part equals this part, then we will be done, which is what will be the focus of our proof. So how can we proceed from this? Well, if we consider this triangle, and if we are interested in finding sine of A, for example, what is the sine of A? Well, sine is defined as the opposite divided by the hypotenuse, so we have y divided by c. Which means for y, we can write c sine of A. Okay, we will substitute for y in this equation in a minute. It may take longer than a minute, but first let's find an expression for x in terms of A and other lengths. So, if this time we consider cosine of A, this will be by definition adjacent over hypotenuse. So what is the adjacent side? Well, the adjacent side is this part, right? The one in orange. Well, what is it? It is what is left of B when we subtract x. So we have B minus x divided by the hypotenuse, which is C. So we see that if we multiply both sides by c, b minus x is equal to c times cosine of A. And if we solve for x, we can see that x is equal to b minus c times cosine of A. Now we are ready to make our substitutions for x and y in this equation. So let's get started. And I am going to do it with red. That's how I do important stuff. A squared is equal to, instead of x squared, I am going to substitute the formula that we found here. So I write b minus cosine, I keep saying cosine, but we first have c times cosine of A. This is squared, and then plus we have y squared, so we have this thing, which is c sine of A, and it is squared. Alright? Now let's open the parentheses in the first term especially. Let's distribute the power. So we square the first term, then we put a 2 and multiply the terms to get this, and we square the second term as well. All right, and then we move on to the second term, to this term. To do that, to square it, we simply say c squared then sine squared a. Well, if you consider these two, you can see that you can factor out a c squared to leave you with cosine squared of a plus sine squared of a. Well, what is cosine squared of any angle plus sine squared of that angle? You might know this, but in case you don't know it, I want to make a quick proof of it here. Maybe I can do it on a new page, and then we will return to this one. So I am asking the question, what is cosine squared of theta plus sine squared of theta? Well, if we have a triangle, a right triangle, and it does not look like a triangle. Okay, this one will look like a triangle. So we have a right triangle, and this angle here is theta. Well, then cosine is, and I will name this side opposite, which is, I represent with a O. This is the hypotenuse, and this is the adjacent. So cosine is adjacent divided by hypotenuse, which we square. So we get a squared divided by h squared. Well, what is sine? Sine is opposite divided by hypotenuse. So we have, since we square it, o squared divided by h squared. Well, we have a common denominator, so we can add the numerators. What is a squared plus o squared? Well, from Pythagorean, from the law that is very famous, the Pythagorean theorem, we know that this will give us the square of the hypotenuse. So this will give us h squared. We divide by h squared, so we get 1, which means that this is the cosine squared of theta plus sine squared of theta is equal to 1. So if we'll use this idea, and in this case, instead of theta, we just have a, it doesn't matter, we simply have 1 here. So we have c squared times 1, we just have c squared as the sum of the last two terms. Now then, let's write a squared one more time. A squared is equal to b squared minus 2cb cosine of a plus c squared. And look at the law of cosines that I stated at the beginning. The formula that we derived is exactly the same with it. So we actually proved the law of cosines. Now you could do similar proofs for the other sides, and I'm just going to write the formulas for them. Obviously, you can do them with the same kind of reasoning. For example, if you want to find b squared, you would do a squared plus c squared minus 2 ac cosine of b. And for c squared, you would do c squared is equal to a squared plus b squared minus 2a b cosine of c. Alright, these are the equations that you would get. Also notice that if you substitute 90 degrees for any of the angles here, for example, in the first one, if you substitute 90 degrees for a, since cosine of 0 is, since cosine of 90 degrees is 0, this term would cancel and you would be left with a squared is equal to b squared plus c squared, which is the Pythagorean theorem. So this is a more general form of Pythagorean theorem. But notice that we needed to use Pythagorean theorem at the start, for example here, to be able to arrive at this more general result. But it is great to see that our calculations are consistent with each other. So this is it for this video. I hope you found it helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.